These are topic tests which should be attempted once you have covered the basic concepts of a topic. These topic tests will help you understand where you stand in terms of solving the questions in a test or an exam. The video is about the analysis of the test and analysis of each question with solution. So once you've given the test, ideally only then look at the video just to compare as to what could have been a good attempt and how you fared in the test. Also, if you like the test, there are more than 200 such topic tests available on all topics in our Bodhee Prep app. So the app for which is in the description below. Just download that app and get cracking on the tests. This video talks about test 3 of ratio proportion as mentioned in the app. Overall, this test is of moderate level of difficulty and therefore a net attempt of 6 questions. This is after eliminating the wrong answers. A good attempt would be 6 net correct questions. And once you're going through the test, it should take you about 20 to 23 minutes to go from 1 to 10 question number. Obviously, I'm not saying that we'll be able to solve all the questions in 23 minutes, but attempting all of them and then getting a net 6 correct should happen about this time. Moving on to the questions. Question 1 here says, the number of cricket balls with 3 persons are XYZ and they're in the ratio 2:3:5. If Y and Z give 36 balls each to X, then X will have 2/3 as many balls as Y and Z together have. What is the total number of cricket balls that the three have? Now, if we look at XYZ, the number of balls suppose was 2X, 3X, and 5X. Y and Z give 36 balls each to X. So Y gives 36 balls, Z gives 36 balls. So now X will have 2X plus 36 plus 36, 72 balls. Y will have 3X minus 36. Z will have 3X minus 36. 5X minus 36. And because of this, it says X will have 2/3 as many balls. So X is equal to 2/3 of what Y and Z have together. So we're basically solving for this. 2X plus 72 is equal to 2/3 of 8X minus 72. Cross multiply, 3 goes here, 6X plus 72 into 3 is equal to 16X minus 72 into 2. So 16 minus 6X is 6X, 10X, 72 into 3 plus 72 into 2. So 10X is equal to 72, we take common, 72 into 2 plus 3 is 5. Dividing, X becomes 70 into 5, 72 into 5 by 10, 5 2s are 10, 72 2s are 30, 72 divided by 2 is 36, so X becomes 36. What is the total number of balls the 3 have? The total number of balls that the 3 have is 2X plus 3X plus 5X, which is 10X. The value of X has come out to 36, so the total number of balls will be 360. And that becomes the answer. Now, in terms of level of difficulty, this question would be an easy question, just one equation, and we get the answer. Should not take about 1.5 minutes, more than 1.5 minutes to solve. Certainly a question that should be attempted in exams. Manga, Ranga, and Manga have some marbles with each of them. 5 times the number of marbles with Ranga equals 7 times the number of marbles with Manga. So if the number of marbles is M, R, and B respectively, 5 times of R is equal to 7 times of M, while 5 times the number of marbles with Manga. 5 times of M is equal to 7 times of numbers with Manga. So 5 times of M is equal to 7 times of B. What is the minimum number of marbles that can be there with the 3 of them put together? Now, if we take M as 35x, why I'm taking M as 35x? Because it will be divided by 5 here, and here it will be divided by 7. So, assuming that M is 35x, 7 5 is 35, we can write 5 into R is equal to 7 into 35x. 5 7s are 35, so R becomes 49x. 7 7s are 49. And here we can write 5 into 35xm is equal to 7 times of b. 7 5s are 35, so b becomes 5 5s are 25x. So the number of marbles that they have together is 35 plus 49 plus 25. 35 plus 25 will be 5, 50, 60, 60 and 109x. the minimum value that x can take is 1. For a decimal value, we'll get a decimal answer, which is not possible. Number of marbles has to be integral. So the minimum number of marbles with them will be when x is equal to 109. Again, ratio based question, because there are two different ratios. The concept of continued ratios is there. I am saying a moderate question, but should not take about more than 2 minutes to solve. Mr. Machipal's aquarium contains red, black, and yellow fishes in the ratio 5:1:4. Some red, black, and yellow fishes. Some red and yellow fishes die because of overfeeding. As a result, the ratio of number of red, black, and yellow fishes in the aquarium becomes 5:3:7. What is the minimum possible number of fishes that were there in the aquarium initially? Suppose the number of fishes initially was, it was in the ratio 5:1:4, red, black, yellow. Also, when some red and yellow fishes die, the black fish become in the ratio 5:3:7. So the number of black fish becomes a multiple of 3. So what I'm saying is, let this initially be, I'm multiplying this by 3 to start with. So 15x, 3x, and 12x. The number of fish initially is 15x, 3x, and 12x. Some fish die, and therefore now the number of fish left is in the ratio 5:3:7. Since black fish do not die, 3x will remain 3x. Since the ratio is 5:3:7, the other number should be 5x and 7x. And therefore, initially the number of fish that was there was 5 plus 12, 27 plus 330x. The number of fish which died, 5 minus 15, 10x. Red fish died, 12 minus 7, 5x. 5x yellow fish died. So 15x fishes died. And therefore, the number of fishes left with is now 5 plus 3, 8 plus 7, 15x. What is the minimum possible number of fish that were there in the aquarium initially? Now, since the number of fish which died is 15x, x ideally cannot be, if you look at a fractional value, the fractional value that x can take is 1/3, 1/5, 1/15. In that case, all of these will be integers, but 7 into 1/3, 7 into 1/5, 7 into 1/5 will not be integers. So these values are not possible. So the minimum value that x can take is 1. In that case, all of these numbers individually will also be integers, and therefore the minimum number of fish that had to be there initially will be 30. Again, I would say this is a moderate sort of a question. The concept is very easy, but you'll have to check once for these values. Luckily, since we're getting 7 here, it became an easy question. Solving time will not be very high. You just have to check with the factors of 15, and that should give you the answer. There are 140 students in a school. The number of students who play cricket, football, and hockey are 50, 80, 70. The ratio of number of students who play more than one of the three sports to the number of students who play all the three sports. So basically, if A is the number of students playing exactly one sport, B is the number of people playing exactly two sports, C is the number of people playing exactly three sports. It says the ratio of the number of students who play more than one of the three sports. More than one means 2 and 3. So B plus C to the students who play all three sports upon C is equal to 3/2. So if we say that C is equal to 2x, from here we will be able to say that B is equal to x, because C is equal to 2x. B plus C is equal to 3x. So C, subtracting C from both sides, we'll get B is equal to x. Now we know that A plus B plus C will be the total number of students, 140. If we add the number of people playing cricket, football, and hockey, the ones who play one sport will be counted once, the ones who play two sports will be counted twice, the ones who play three sports will be counted thrice. And this will be 50 plus 80 plus 70. Now, this is the concept of set theory. So, ideally, that would be required to properly solve this question. 580, 130, 200. So, if we take this equation and subtract it from here, A and A cancel, 2B minus B will give us B, 3C minus C will give us 2C, and this should be equal to 60. 200 minus 140. We know that B is equal to X, 2C is equal, C is equal to 2X. So 2 into 2x is equal to 60. 2 2s are 4, 1 plus 5. 5x is equal to 60 or x is equal to 12. The question for which we are solving is how many students play exactly two of the three sports. Exactly two of the three sports is B, which is x. Hence, the answer will be 12. Now, unless you're comfortable or understand the concept of set theory, this question will be a little difficult to solve. But otherwise, not a very difficult question. I'll say it's a moderate question, might take up to 2.5 minutes to solve, and then you can get the answer. The cost of diamond varies directly as the square of its weight. Cost varies directly as the square of its weight. Once this diamond broke into four pieces, and the with the weights in the ratio 1 is to 2 is to 3 is to 4, assuming that the weights were actually 1, 2, 3, and 4 kgs respectively of the four pieces. When the pieces were sold, the merchant got rupees 70,000 less than the original price. Now, what will be the original price? Suppose the equation for cost is k w square, where k is the constant, w is the weight. If a stone breaks into four pieces with weight 1, 2, 3, 4, the total weight of the stone will be 4 plus 3, 7 plus 2, 9 plus 1, 10 kgs. So the original cost will be C is equal to K into 10 square, which is 100K. This was the original cost. What will be the new cost? There will be four parts. So the cost will be K into W square, K into 1 square of the smaller part, K into 2 square of the second stone, K into 3 square of the third stone, and K into 4 square of the fourth stone. So 1 plus 4 plus 9, 9, 13, 14, 16, 30K. 16 plus 9, 25, 4 square, 3 square, 2 square, 1 square, 10, 20, 30, 30K. And therefore, we can say that the cost has decreased by 100K minus 30K, which is 70K. This is given as 70,000 in the question. The K that I'm using here is not for 1000 per se, it is for as a constant of proportionality. But if we equate this, we'll get the value of K as 1000. What is the original price of the diamond? The original price of the diamond was 100K. So 100 into 1000, which gives us the value as 1 lakh rupees. Option C. Again, this question is a direct proportionality question, and similar questions about stones breaking into smaller groups or smaller parts have been asked in previous questions. A very similar question was there in CAT 2022 23 slot 2 as well. So it's a moderate level of difficulty question, might take about 2.5 minutes to solve. But since such questions have been asked, you should ideally be familiar with this question. At the beginning of the year, the populations of three countries ABC were in the ratio 4, 5, 6. During that year, the respective populations of the three countries increased by percentages which were in the ratio 2, 3, 4. So let the populations be 4x, 5x, and 6x. These are the populations of the three towns ABC. And the percentage increase be 2y, 3y, and 4y, respectively. Right? Now, the population of A and B at the end of the year. So, population of A at the end of the year is 160. So, we can say 176 million. So, we can say, suppose this population also, we are taking in million only, population in million. So, we can say the initial population 4x into 1 plus 2y upon 100. Initial value into 1 plus percentage increase upon 100, multiplying factor is the final value. And for B, 230 is the final population. This will be 5x into 1 plus 3y upon 100. We have two equations in x and y which we can solve. So suppose this is equation 1, this is equation 2. Dividing equation 1 by equation 2, 176 by 230 is equal to 4 by 5. X and x cancel. Now this can be written as 100 plus 2y upon 100. This will be 100 plus 3y upon 100. If we divide 100, 100 cancel. So 100 plus 2y into 100 plus 3y. We can cancel this out as well. 4 4s are 16. 1 4 6 4 4s are 16. 5 4s are 46. If we further divide by 2, 22 by 23. We are cross multiplying. So this comes here 2200 plus 66y is equal to 2300 plus 46y. So 100 is equal to 20y or y is equal to 5. So the percentage increase is 10%, 15% and 20%. If we put the value of 5 here, we'll get 176 is equal to 4x into, this becomes 1 plus 10 upon 100, which will be nothing but 1 by 10 plus 1 or 11 by 10. 11 4s are 44. 44. This will come out to 4. 44 into 4. So x will be nothing but 40. So the initial populations here are 40 into 4. 160, 200, 40 and 240. These are the initial populations. Find the population of C at the end of the year. The new population of C will be initial population 240 into 1 plus percentage increase, 1 plus 20 upon 100. So this becomes 1 by 5, 240 into 6 by 5. 5 4s are 20, 8s are 40, 6 4s are 24, 6 8s are 48. 288 million becomes the answer. Population million, 288 is the answer. Now, in terms of level of difficulty, the concept of multiplying factor is used here as well. So, I'd say moderate level of difficulty. The only problem here could be this question might take some time to solve. But if percentage and ratio are two things that we understand, getting the answer will not be very difficult. But again, because there is calculation involved, a moderate level of difficulty question. The age of a person k years ago was half that of what his age would be k years from now. So suppose today, t minus k years, t plus k years. The age of a person k years ago. So if the age today is x, k years ago it would be x minus k, was half of what his age would be k years from now. K years from now, the age will be x plus k, right? And this age was half of what it would be k years from now. So we can say x plus k is twice of x minus k, which gives us x plus k is equal to 2x minus 2k, which means x is equal to 3k. So the age here is 3k. Here it becomes 4k. Here it becomes 2k. Next, the age of the same person p years from now will be thrice of what his age was p years ago. So suppose today t plus p and t minus p. The age today is 3x years. P years from now it will be 3k plus p. 3 p years ago it would be 3k minus p. And this age p years from now will be thrice of what it was p years ago. So 3k plus p is equal to thrice into 3k minus p, which means 3k plus p is equal to 9k minus 3p. So 6k is equal to 4p. 6k is equal to 4p. We have to find out what is the value of the ratio k is to p. So from here we can write k upon p. Since p comes down, k will be 4 by 6 or 2 by 6. So the ratio of k by p is nothing but 2 is to 3. Again, the question is not very difficult. Ideally, I'd call it an easy question, but again, because ages are involved, there is sometimes we can get a little confused, especially when since numbers are not used, it becomes sometimes a little difficult to put in the different time frames and then compare them. But overall, I'll say this is an easy question because not calculations are so limited. Just two equations had to be solved, very basic equations. So the solving time will not be very high, easy to moderate level of difficulty. The ratio of present ages of Binny and Coral is the same as the ratio of ages of Anu and Binny 6 years ago. Coral 6 years from now will be as old as Anu was 6 years ago. Anu, Binny, Coral. Binny, Coral, Anu. We're looking at three different parts. Today, 6 years ago, t minus 6, 6 years later. So Coral 6 years from now will be as old as Anu was 6 years ago. So if Anu 6 years ago was X, Coral 6 years from now will be the same age. So today Anu's age is X plus 6, 6 years added, and Coral's age is X minus 6. Next, the ratio of present age of Binny and Coral. Suppose today Binny is Y, so the ratio of age of Binny, y upon X minus 6 is the same as ratio of ages of Anu and Binny. Now, Binny 6 years ago will be y minus 6. So, ratio of age of Anu and Binny 6 years ago. 6 years ago, and Anu and Binny will be of the ratio y x upon y minus 6. which means y into y minus 6 is equal to x into x minus 6 is the equation that we get. Also, the present ages of two of them, exactly two of them are perfect squares. Out of these three numbers, two numbers have to be perfect squares. If we look at squares 1, 4, 9, 16, 25, 36, and so on, will not go beyond this because the maximum sum is 48, cannot have 49. 48, okay. So in this case, we are looking for an expression. Now, since we're looking for a possible solution, I'm trying to make equation which will satisfy. So if we take x is equal to y and then try to solve, this equation will be true if x is equal to y. So if we put this as x, the age of the three people becomes x minus 6, x and x plus 6. Now, if you look at the list of squares, we'll realize that there are no two squares which have a difference of 6%. Because here the difference is 6, here the difference is 6. But if we look at these two numbers, 4 and 12, they have a 4 and 16, they have a difference of 12. So this number, if you put as 4 and this as 16, x becomes 10. If this here is 10, this is 4 and this is 16, that means this would be 10, this would be 10, and this will become 4. Therefore, the ratio of 10 is to 4 will be the ratio of 10 is to 4. These two ages will be same, and out of these three, two numbers are perfect squares will also be true. So if we take x is equal to y, we get a possible solution, in which case the age of or sum of ages is 16 plus 4, 20 plus 10, which is 30. Hence, option B is a possibility. In terms of level of difficulty, I will call this a difficult question for the simple reason that solving equation, making cases is involved. In an exam, it might not strike very quickly, and therefore also the solving time will be pretty high. So, a difficult question overall. The amount of water consumed by Ravi varies directly with the temperature. Amount of water varies directly with the temperature when humidity is constant, inversely with humidity when temperature is constant. So we can say the amount of water varies with T into 1 by H or T by H, and therefore amount of water consumed is K into T by H. K is the constant, T is the temperature, H is the humidity. Ravi consumes 625 ml at 25-degree temperature and 36% humidity, which means we can say the value of K is nothing but 625 into 36 by 25. This is 25. So this becomes, I think, 900. 25, 4, 900. So K becomes 900. Therefore, the amount of water consumed is 900 T by H. When the humidity is 45%, what is the increase in quantity of water consumed for every 1 degree C? Now, suppose we say that A1 is consumed when temperature is T at humidity 45. A2 is consumed when temperature is T plus 1 degree more at when humidity is 45. We have to find the increase in water. So increase in water will be A2 minus A1. This will be 900 into T plus 1 upon 45 into, sorry, minus 900 into T upon 45. T and T get cancelled. Basically, 900 upon 45 becomes common. T plus 1 minus T becomes T, and therefore the difference of water consumed will simply be 900 upon 45, which will be 20 ml, is what we started with. So for every increase in the temperature by 1 degree C, the water consumed will increase by 20 ml. Again, moderate to difficult level of question, because understanding the fact that the difference has to be taken might be difficult. Also, proportionality might create an issue because there are two different variables. Hence, I'm saying moderate to difficult unless the concepts are very clear. Solving time should be around 2.5 minutes. Rupees 45 was distributed amongst A, B, and C. From that amount, they received A, B, C spent 110, 120, 140. The amounts left with A, B, C are in the ratio 3:4. A and B is 3:4, B and C is 5:6. What was the amount that B received? Suppose after spending their amounts, the amount left with A and B is 3:4. B and C is 5:6. We combine the two ratios. I multiply this by 5, becomes 15:20. Multiply this by 4, becomes 20:24. Therefore, if you look at the amount left with A, B, C, if A has 15x, B has 20x, and when B has 20x, C has 24x. This is after A spent 110 rupees B spent 120 rupees, C spent 140 rupees. So initially A had 15x plus 110, B had 20x plus 120, C had 24x plus 140. So the total amount of money that ABC had together will be 24, 48, 15. 9, 44, 2, 4, 5, 59x plus 1, 2, 3, 370 rupees. This is the amount of money that they had initially. And this is nothing but 4,500 because that was distributed. So we can write 59x plus 370 is 4,500, which means 59x is equal to 4,200 minus 70. 4,130. 4,130. X is equal to 4,130 upon 59. 9, 6 are 53. 590. 30, 45. 8, 400, 472, 7. 7, 7, 9, 63, carry forward 6. 7, 5 is 35, 6, 41. So 0 is there. So 70. This comes out to 70. We have to find the amount that B received. B received 20 into 70 plus 120, which is 1400 plus 120, which is 1520. Again, I'd say not a very difficult question. Moderate level of difficulty should take about 2.5 minutes to solve. And again, these are questions that we would have come across while practicing as well. Similar questions. So maybe something that could be looked in the exam. Now, if you look at the overall analysis, as I said initially, moderate level of difficulty for the oral test, 6 would be a good attempt, about 20 to 23 minutes to solve. And the number of questions that could be looked at for me would be 1, 2, 3, 5, 7, 10. If I'm choosing questions that I should attempt, these are the first things that I'd look for. 1, 2, 3, 5, 7, 10. Which are these ones? They should have been attempted. Direct equation solve. Should have been attempted. Continued ratio. Should have been attempted because the numbers were easy and that 7x made the calculation much easier. Could have been left if set theory is not something that you are comfortable with. This should have been done. Repeated question. This could have been left because there was calculation word. This I thought was an easy question. This had to put the value of K and P. Should have been attempted. This could have created problems because here we were looking at a possible solution. So cases would be formed. Again, if you're not comfortable with proportion, this is a question that could have been left. Since I've done this kind of questions earlier, this is one question that I would attempt. So therefore, my attempt would be 1, 2, 3, 5, 7, 10 in this test.